Number 8, find the equation of a normal to a curve. Find the equation of a normal to a curve. R is equals to 7 minus 4 cos theta at theta is equals to pi over 2. Find the equation of a normal to a curve. R is equals to 7 minus 4 cos theta at theta is equals to pi over 2. So the first thing you need to do for you to get the equation of the normal, you must have one known point along the normal line, isn't it? With one unknown point, and you must know the gradient of the normal, isn't it? And the gradient of the normal, you can only get it by getting the gradient of the tangent first, isn't it? Isn't it? And the gradient of the tangent is the gradient of is the derivative of the curve, isn't it? So let us start. When theta is pi over 2, that is the same as 90 degrees. If your calculator is set in D, isn't it? 180 divided by 2, isn't it? Are we together? So you start. What is R when theta is pi over 2 or when theta is 90 degrees? What is R? R is going to be 7 minus 4 cos pi over 2 or cos 90 degrees when you are in D. Don't ever put pi over 2. If you've set calculator in D, if you've set calculator in D, you put 90 degrees. If you've set calculator in R, you put pi over 2, because the calculator only takes the command you've given it, isn't it? If you put pi over 2 where there is D, it will see pi over 2 as degrees. Meaning you will see pi over 2, it will be the same as 3.14 divided by 2. It will see it as that, as 1.57 degrees. Are you seeing that? You must be very careful. So what do you have here? 7 minus 4 cos 90. Cos 90 is 0. That is 7, isn't it? Are we together? So what have you found? You found R to be 7 and theta to be, what is theta? 90 degrees. So when theta is 90 degrees, the radius is 7. So it is this polar form we convert in Cartesian form to get the point xy, isn't it? That point xy, if this is the curve and this is the tangent line, then the normal is the line perpendicular. So this is the normal. It is the line perpendicular to the tangent, isn't it? Are we together? So it means this point you found r theta 790 degrees, we change it into xy so that we know exactly what are the x and y coordinates of this point, isn't it? Are we together? Yes. This is this polar form. So can you convert that? Convert that point. So start, what is x? We know very well that x is r cos theta. So your r, you know there r is 7 cos theta. 7 cos 90 degrees or cos pi over 2 in pi radians. What do you get? It is? What have you found? You found 0. Good. So you found x is 0. Then what is y? Y you know is r sine theta. So what is r? R there is 7 sine 90 degrees. So you found y to be? Work it out. What is y? Yeah, you should know those functions. You should just see them in your brain when you are doing it. So what do you have? You have y there is 7. Those are things you did in Form 2, isn't it? And you were very happy about them. So you found the known point, the tangent and the normal are sharing. So it is that known point we are going to use to get the equation after determining the gradient, isn't it? So how do we determine the gradient of the normal? We have to get the gradient of the tangent, and the gradient of the tangent we must get it from the derivative of the curve, isn't it? So it means here we have r as a function of theta. So it means we differentiate r with respect to theta. If you differentiate a constant, you get 0, isn't it? Then here -4 is a constant. If we differentiate cos theta, we get negative sign. We talked about that, isn't it? If you differentiate a constant, you factorize outside, then you differentiate cos theta, you get negative that. If you differentiate a constant, you get 0, isn't it? Are we together? So if this negative is positive, so you get 4 sin theta. So what is the r over the theta when theta is pi over 2 or 90 degrees, isn't it? So where there is theta, if you put pi over 2, what do you get to be the r over the theta? 4 times sine pi over 2, you get 4? 4, isn't it? Because sine pi over 2 sine 90 degrees is 1, isn't it? 1 times 4, you get 4. So that is the first thing which comes. You use the equation you've been given to get that derivative, isn't it? So we found the r over the theta to be 4 at pi over 2. So you record that the r over the theta is equals to 4. It is now that the r over the theta we want to use to get the derivative of the curve, isn't it? The derivative of the curve is given by dy over the x is the derivative of the curve, isn't it? So you divide both the numerator and denominator by the theta, isn't it? If you divide both the numerator and denominator by the theta, you get dy over the theta divided by the x over the theta, isn't it? So it means for us to get the derivative of the curve, it implies that we have to get dy over the theta, isn't it? And we also need to get the x over the theta. That is when we are able to get the derivative of the curve, isn't it? Are we together there? So what is dy over the theta? You know very well that y is always r sine theta. If that r is a function of theta, then this is a product of two functions. So you use the product rule, isn't it? You take one step and you differentiate this, then plus you take the other step and you differentiate the remaining, isn't it? Are we together? So differentiating y with respect to theta, we get dy over the theta to be, if you take r step and you differentiate sine theta, you take r step, if you differentiate sine theta, you get cos theta. Then you are differentiating a theta variable with respect to theta, you remain with the theta over the theta. That is silent, isn't it? Then you now have plus, you now take sine theta step and you differentiate r, isn't it? If you differentiate r, you get 1, and which derivative do you remain with? The dr over the theta, because you are differentiating a r variable with respect to a theta variable, so you remain with the dr over the theta. Are we together there? But if you differentiate just r like this is a polynomial. 1 times 1 is 1, you reduce the power by 1, you get r raised to 0. Anything raised to 0 is 1, isn't it? Good. You must multiply with the derivative left there. But now what do we want? We want dy over the theta when theta is pi over 2 or 90 degrees, isn't it? Are we together? Because that is the point we are dealing with, isn't it? So where there is theta, if you put 90 degrees, what do you get to be dy over the theta? R cos theta, we know is x, isn't it? R cos theta is x. So what was the x value? 0 plus sine theta, that is sine theta. Our theta is pi over 2 or 90 degrees, isn't it? So sine 90 degrees is 1. Then what is dr over the theta? Dr over the theta you found to be 4. So at the end, you get dy over the theta to be, are you seeing that? So we've now found dy over the theta to be equals to 4. Move to the next one. We now look for the x over the theta, isn't it? Let us now look for the x over the theta. For you to get the x over the theta, meaning you must know x, isn't it? What is x? R cos theta, isn't it? R is a function of theta, it means it is a product of two functions, isn't it? We are now differentiating x with respect to theta using the product rule, isn't it? So if you differentiate x you get 1, isn't it? Are we together? But which derivative do you remain with? You remain with the x over the theta, because you are differentiating an x variable with respect to a theta variable. You remain with the x over the theta. Are we together? So that one is equals to 0. Take r step and you differentiate cos theta, meaning you take r step and you differentiate cos theta. If you differentiate cos theta, you get negative sine theta, isn't it? So you now have negative r sine theta because you took r step as you are differentiating the other. Are we together? Then plus, you now take cos theta step and you differentiate r, isn't it? So if we now take cos theta step like that, if we differentiate r, we get dr over the theta. Because differentiating r, you get 1. But which derivative do you remain with? You are differentiating an r variable with respect to a theta variable. So you remain with the r over the theta. Here you are differentiating a theta with respect to theta, you remain with the theta over the theta. Silent, isn't it? 1, isn't it? Are we together? Good. So from there you just do the substitution. This is negative r sine theta. So r sine theta is y, isn't it? Are we together? R sine theta is y. So it's like we have negative y. But what is your y value? 7. So it's like we have negative 7, because we are substituting it where theta is pi over 2 or 90 degrees, isn't it? Good. So there you have, this one is negative 7, then plus, what is cos theta? Cos theta, that is cos pi over 2 or cos 90 degrees into d. You have 0, isn't it? So this one will be 0 times dr over the theta, which is 4. 0 times anything is 0. So here you just remain with the negative 7. So you found dx over the theta to be equivalent to negative 7. So having found that, it means we can now get the y over the x, isn't it? We can now get the y over the x. We can now get the y over the x at that point when you have at point pi over 2. We found the y over the theta to be what? You were just doing normal substitution. The y over the theta you found to be 4, isn't it? Then the x over the theta you found to be negative 7. So what is the y over the x? The y over the x is 4 divided by negative 7, you have negative 0.57. Or you can just leave it as negative 4 over 7 like that. There's no problem, isn't it? So the y over the x is negative 4 over 7, isn't it? It's negative 4 over 7. We are done with that. So what do we know? We know that the derivative of the curve is the gradient of the tangent, isn't it? The derivative of the curve is the gradient of the tangent. So we know that gradient of tangent is equals to the derivative of the curve. So if you say the gradient of the tangent here is m to be the derivative of the curve, then we have m is the derivative of the curve, which is negative 4 over 7, isn't it? Now we want the gradient of the normal, isn't it? Gradient of the, because it is the equation of the normal we are looking for, isn't it? So what is the gradient of the normal? Gradient of normal. So if you say gradient of the normal is m1, you know normal is perpendicular to tangent, isn't it? Meaning gradient of tangent times gradient of normal, you are supposed to get negative 1, isn't it? So can you now get the gradient of the normal? Gradient of the tangent is negative 4 over 7 times gradient of the normal is negative 1. So if you do that, you get it is 7 over, you multiply both sides by negative 7 over 4, so that you remain with 7 over 4 to be the gradient of the normal. Are you together? So the gradient of the normal we found to be 7 over 4. And after that, we found the known point xy to be 7, 0. So if we have one known point at the gradient, see, we get the equation. Are we together? You get the equation, isn't it? Gradient is change in y over change in x. So change in y is y minus 7, change in x is x minus 0, which is just x, isn't it? This is the gradient, which is equivalent to 7 over 4, isn't it? So if you simplify that, you get y is equals to 7 over 4x plus 7. X goes to the other side, you get 7 over 4x. Then negative 7 going to the other side becomes plus. So y is equals to mx plus c, where this is the gradient, isn't it? And c is the intercept. So you found the equation of the normal to that given curve. Are we together? Good.